Question 6 IAL M1 Edexcel Jun 16. We've got a situation where we've got two cars running kind of in the same direction. They're given a diagram to avoid any confusion. They're basically running side by side to each other. We're told that car A starts to move with constant acceleration for 3.5 seconds, and then it moves to a speed of 14 meters per second. So we can use V equals U plus AT. We have V is 14, U is 0, so and the T is 3.5, so it's A times 3.5. So A equals to 4 meters per second squared. You're not going to find many easier marks on an M1 paper than that. Let's look at B then. Then it talks about car B starts to move at time t because it's 0 in the same direction as car A. So let's say they're both moving along this track, and A is then moving with, and this one accelerates, but A accelerates initially and then moves with constant speed, 14 meters per second. So let's do A first, and then just put B on top of it. Okay, so A, as we've just seen, accelerates 4 meters per second, and then it moves at a constant speed of 14 meters per second, like that. Okay, and that being 3.5 here. Now that's for A. Now for B, we've got it moves with a constant acceleration from the start at 3 meters per second, which is obviously slightly less than this because we know that this is moving at accelerating at 4 meters per second, so it's less steep. Okay, and it goes to the point there. Let's draw it again. It's not straight enough for my liking. That's better. Okay, it moves up there, so it'll actually get to a point where it overtakes it, so it has to go beyond. It will have to get up faster at some point, because otherwise it couldn't overtake it unless it gets faster for some part of the journey, because most of it it's slower. And we can label that point T there. So that's our velocity time graph, or speed time graph, for the interval asked for. Okay, now the next part, 8 marks for it, was setting up an equation. Right, okay, so looking at the equation here, looking at the situation, we're going to need the speed that this ends up at. It will be equal to 3t, because it's accelerating at 3 meters per second and squared, so the gradient has to be 3, so 3t divided by t is 3, so that's 3t. So that's the first thing. Now we have to use the fact that the areas are the same. That's these two areas here, that area there, as compared to this area here. So those two areas have got to be the same. So let's just consider the area of underneath A, this one's B here, underneath A. I'm going to split it into the triangle and the rectangle, although you could consider the whole trapezium, and that's the same thing really. The area of this triangle, which is part of the area I've got in red, it's half base, which is 3.5, times by height, which is 14. Then we need the area of this rectangle here, the area of the rectangle marked there. Well, this side here is t minus 3.5. And the height here is 14. Okay, and then that equals the area of this triangle here. Okay, the triangle there that I've just rubbed out. I've got the red one there as well. The area of that triangle there is equal to half base, half times t times 3t. Okay, so we just have to solve that. So equation, so area underneath must be equal because it's the same distance. So I'm going to multiply both of these by 2 and then do a bit of work with this to avoid any fractions, because I can see I'm going to get 1.5 t squared when I get the quadratic there. So I'm going to multiply by 2 and then multiply. So multiplying this by 2 and then 3.5 times 14 gives me 49. So I'll multiply out this bracket here. 2 minus 3.5, but I've got to multiply that by 2 as well, which is 28. And multiplying this by 2 and then multiplying out the bracket is 3t squared. Okay, now rearranging that, we get 3t squared. Now the term in t is going to be 28 times t, bringing to the other side, which is minus 28t. And then we've got 49, take 3.5 times 28, that's 49 minus 98, which is minus 49, bringing to the other side is plus 49. Now before we reach for calculators, often these questions will factorise, and so I think it'll be a bit quicker. Almost to the extent I'd be a little bit worried, I'd be checking if it doesn't, because virtually most of them I've seen do factorise. But this isn't too bad one, because we know both signs are negative, because we've got a positive sign there and a negative there. We must have a 3t and a t. Now 49 and a 1 just doesn't work out, so it's got to be 7 and 7 if it works at all, and we can't see it does work. That does work. Now it gives us two values. T is equal to 7 over 3 and t equals 7. But we must reject this t equals 7 over 3 solution, because we know that t has got to be greater than 3.5. So the answer is this one here. And part D, only 1 mark. Well, we now know that t is 7 and the distance is this. We might as well put it in that side, easy enough. So the distance is equal to 3t squared, so it's 3 over 2t squared. Right, so that's 3 over 2 times 7 squared. And that equals to 73.5 meters. And then finally they want us to do another graph, but an acceleration time graph. Occasionally you get asked for these things, not that often, but we've got to know what to do when we are. Okay, so put in A on, we know that A initially accelerates and then it goes at a constant speed. Okay, like that, for 7 seconds to 3.5. Let's mark a little dotted line to show that's the thing for A. And B just carries on at a constant acceleration at 3 meters per second. So B does something like that. Okay, and that is question 6 done.